morning. Today, we are going to see on the topic available transfer capability. That means ATC in restructured power market. What is this ATC? So, in restructured power market, many companies want to move the power over the same grid. Obviously, many generation companies want to send their power in the same grid. But the grid has some physical limits. So operators must avoid overloads and blackouts. So at that same time, they must allow fair market access. So that is also there. So this ATC, available transfer capability, tells the market how much more power can still be transferable safely. So by using this ATC, so can tell the market, restricted power market, how more power can still be transferred safely. So this is the main use of ATC in restructured power market. The same thing, we are comparing this ATC with the highway analogy. So what we are doing is we are comparing this TTC. So this all terms we have seen in detail about in our previous class. So if not, you go to my previous class and just you can learn more on this TTC, ETC, TRM, CBM and ATC. So TTC, total transmission capability. So we are just comparing this with highway analogy. So TT is nothing but maximum vehicles that the road can hold. So what is existing transmission capability is called already driving on the road. So what is this TRM? That is transmission reliability margin, is nothing but a safety buffer. Okay, safety buffer. That means reliability margin. Next, capacity benefit margin. So that is nothing but a emergency lane. Okay, emergency lane. Next is nothing but ATC, available transfer. That is we are comparing with the free lanes left. Okay, so that we are comparing with the highway analogy. What is the formula for calculating the ATC? Already we have seen in our previous class. So ATC is calculated by ATC is equal to TTC minus TRM minus ETC minus CBM. Say for example, what is this TTC? That is total transfer capability. So simple meaning like a physical bar security limit. Okay. Next, what is this TRM? Transmission reliability margin. That means safety margin. Okay, safety margin that the power transfer is up to which the power transfer is possible. Next is existing transmission commitments. So existing already scheduled, whatever is already scheduled. That means whatever already transmission is happening in that particular network. Next is CBM, capacity benefit margin. That means emergency reserve. So why this ISOs care about this ATC? Why this ISOs, independent system operator, care about this ATC? Since independent system operator uses this ATC to prevent this congestion in the transmission line and also to maintain the reliability on the transmission line and enabling the competition among the transmission companies. Next, to publish the transparent data on the OASIS website, open access same time information system website, and approve or reject the transmission request easily by seeing the ATC. ISOs can easily approve or reject the transmission request. So methods for calculating ATC, different methodologies are used depending on the time availability, system size, required accuracy, and as well as market versus the planning studies. Okay. So if you take what is this linear sensitivity? That means PTDF method. Okay, that uses power transfer distribution factor method. Linear sensitivity, power transfer distribution transfer method. So what is the basic idea of calculating linear sensitivity method? Is it uses a PTDF, that means power transfer distribution factors. So this PTDF shows how much flow on the line on the transmission line. If how much flows on the line changes if 1 megawatt is transferred from bus M to N. And also it assumes the DC load flow. That means a linearized system. So what is the main formula for calculating ATC using PTDF is nothing but ATC N. That means buses from M to N is nothing but minimizing I. Uh, I means it is nothing but a number of transmission lines. Okay, so Fi maximum minus Fi comma 0 divided by PTDF I comma Mn. So Fi is what? Fi of maximum is what? Line limit. Okay, so Fi 0 is what? Present flow. Okay, present flow. Fi naught is nothing but the present flow. Fi 0. Next, what is this PTDF? Means you already we know power transfer distribution factors on that particular transmission line between that bus M to N. That means sensitivity of that particular line. So this is the formula for calculating ATC by using this PTDF, power transfer distribution factor. So we can see a small example how to calculate this ATC by using this PTDF. So line limit is given as 100 megawatt. Current flow is given as 80 megawatt. So PTDF factor is given as 0.4. So what will be the remaining margin? Remaining margin is nothing but 100 minus 80 is nothing but 20 megawatt. That means this ATC M comma N is equal to minimization of Fi maximum minus Fi naught. That means maximum line limit minus present line flow divided by PTD. So maximum line limit is what? 100. Current maximum current flow, present current flow is what? 80 megawatt. So 100 minus 80 divided by this PTDF. This is 0.4. Okay. So remaining margin, that is 100 minus 80 is 20. Remaining margin is 20 divided by PTDF 0.4. So if you calculate this, we can get the answer as 50 megawatt. So available transfer capability by using PTDF is nothing but 50 megawatt for this particular simple problem considered. What are the main advantages of ATC by using PTDF? Is very fast. Okay, so you can calculate the ATC available transfer capability very fast because based on the factor. So dividing with that factor, we can calculate the ATC very fast. Suitable for real-time screening. Okay, real-time screening, it is suitable. Easy for market tools also. What are the main limitations of this ATC model by using PTDF is it ignores the reactive power. Reactive power we are not taking into account, and also less accurate for near voltage limits. These are the main limitations of this particular ATC by using PTDF model. Next comes the repeated power flow method or repeated power flow model. RPF model, repeated power. So what is the basic idea behind this repeated power flow model in the sense? It increases the transactions gradually. It runs full alternating current load flow each time, and also it stops when and constraint is violated. So this is called repeated power flow method. So what is the procedure for this repeated power flow method is start with a base case and increasing the change in the power. Say for example, some 10 megawatt like that. What is the change in the power that we have to increase? What is the change in the power? Example is 10 megawatt, but practically speaking, it depends on that particular problem. So solve the AC power flow method, whereas in previous PTDF, we are going to calculate by using the DC power flow. Here it is AC power flow and checking the limits. Okay, checking the limits. Repeat until the violation occurs. Okay, so this is the procedure for calculating this RPF. That means a repeated power flow method. So example, if you take like start if you take start power as 100 megawatt, so it is collapsing at 150 megawatt. So TTC is 150 megawatt. Why? Because which subtracts the margin to get the ATC. Okay, so the which collapse at 150 megawatt. Okay, so advantages are accurate. Okay, so we need to subtract 150. That means subtract margins to get the ATC. Okay, so TTC is 150 megawatt. Okay, subtract margin to get the ATC. So we need to calculate the ATC. Okay, this margin to get the ATC. So we need to subtract this margin to get the ATC. So what are the main advantages of this repeated power flow method? Okay, so main advantage is accurate. It includes the voltage effects. Okay, so limitation is slow, computationally heavy. Okay, so when compared to that PTDF method, this is having limitations because slow and also computationally it is heavy. That is also there. Next comes the next model, continuation power flow model. So the basic idea of this continuation power flow model in the for calculating this ATC is nothing but it tracks the system behavior smoothly and finds the voltage collapse point exactly. Whereas in the previous model, just we are giving the voltage collapse model where at 150 megawatt, that after this 150 megawatt voltage collapses modeling is like that we are calculated. But here it finds the voltage collapse point exactly, which uses the PV curves. Okay, PV curves concept. Exactly we are using in solar modeling, no? The same PV curve. So in x-axis, if you take like loading, and y-axis, if you take like voltage, the nose point, if you it will come like this. Okay, so this it will come like this. So that nose point, which gives the maximum transfer limit. Okay, so that is also we need to like based on the this power PV curve concept. Also, we are going to nose point which represents the maximum transfer. It also uses the PV curves also. Okay, so what are the main advantages of this power model? That means this continuation power flow model, that is CPF. It is very accurate and captures the non-linear behavior also. What are the main limitations of this continuation power flow model? It's complex and used mainly in planning only. Next comes the optimal power flow. Okay, optimal power flow or security constraint optimal power flow. So the basic idea behind this optimal power flow or security constraint optimal power flow, which formulates the ATC as an optimization problem. And also it maximizes the transfer capability subject to this line limits, like transmission line limits, voltage limits, generator limits, and as well as the contingencies. Next comes the security constraints optimal power flow. So it checks the N1 contingencies. What is this N1 contingency analysis in the sense? N1 contingency analysis ensures the power grid reliability by simulating the failure of a single critical component such as line, transmission line, transformer, or generator to verify that the system continuously operating safely without overloads, voltage violations, or cascading blackouts. So this proactive planning standard maintains the system stability. So this is nothing but the N1 contingency analysis. And also this system, this SCOPF used by ISOs in operational planning. Okay, so this N1 contingency analysis ensures the power grid reliability by simulating. So there will be some specific softwares will be there, which by simulating the failure of the single critical component, such as any component like a line, a transformer, generator, and all, you can easily analyze to verify that system continuously operating safety without the overloads or voltage violation or any cascade blockouts. Okay, so this proactive planning standard maintains the system stability. If you priorly, if you simulate, you can easily maintain the stability. So whatever the, say for example, whatever the fault happens, you can easily, because already you simulated, no, so easily you can know that okay, if the current is going to this limit, so this because already we simulate, so approximately this um, uh, like blockout only happen, or this changes only happen, so such that you can make the rectification action such that you can maintain the system stability. So this security constraint optimal power flow only used by the ISOs, independent system operator, in operation and planning of the transmission lines. So what are the main advantages of this SCOPF model? It is systematic, economically meaningful, and also reliable. And limitation, computationally demanding. Sometimes it is computationally demanding. Next comes the AI bar optimization technique or intelligent techniques for predicting this ATC. So what is the basic idea? If you take like artificial intelligence techniques or neural network techniques, it will train the models by using the historical data. Okay, so machine learning model also, if you take if it will train the model by using historic data and predict the ATCs availability, transfer capability instantly. So what are the techniques involved? ANN technique, genetic algorithm, particles. So not only this, you can also utilize ML, machine learning technique also. And any algorithms, it depends on the data. Okay, so it depends on the data in which you are taking. Based on that, you need to select any optimization techniques, and as well as the neural network techniques or machine learning techniques to predict the model based on the historical data. So, what are the main advantages of this AI or machine learning model or intelligent optimization technique? Is extremely fast and suitable for real-time markets. Okay, so these are the main advantages. Limitations means it requires training. Training will take time. So if you take like AI model, training will take little bit time. So less transparent physically. So that is also one of the these are the limitations of this AI model for calculating AR optimization model for calculating this ATCs. So comparison of this ATC calculation methods. So if you take like a DC PTDF, DC like power transfer this factor. Okay, so power transfer distribution factor. Okay, PTDF. So accuracy, if you take like low, moderate will be there. Speed is very fast, and also what is the main uses to screen. So if you take like ACPTDF, accuracy is moderate to high. Okay, and also speed is fast. Okay, typical uses for real-time system. So mainly used is ACPTDF. Just for screening purpose, we are going for this DCPTDF, but speed is very fast. Next, if you take like RPF method. So RPF is what? So this method, repeated power flow method. Okay, repeated power flow method, continuation power flow method. So here, if you take like RPF, repeated power flow method, accuracy is high, speed is slow, use is for just for plan. Okay, next is CPF method. Okay, continuous power flow method, accuracy is very high, speed is very slow, and typically uses for voltage stability studies. And next thing, if you take like SCOPF, okay, security constraint optimal power flow method. Accuracy is very high. Speed is a medium to slow, and the typical uses for ISO operations. And if you take like A or ANN based method, accuracy is high, speed is very fast. Okay, typical uses for market tools. Okay, so nowadays in the like restructured power market, they are using this AI based method because accuracy also high and the speed is also very fast, and typical uses for market based tools. They are using this AI based ANN method only. By background, they are using all this method also to just for analyzing the things and all. They are using all background. But major, they are using this AI-based prediction method for because speed is very fast and also market model accuracy also high. So and also previously they are using this SCOPF and all, but speed is somewhat slow. The calculation is slow, and the CPF also method also used, and the speed is very slow. Okay, so sometimes they are using the combination of both AI-based SCOPF method for ATC calculation in the market models. Next comes the ATC enhancement techniques. So how to enhance this availability transfer capability means by using the FACS device. If you take like FACS devices, static wear compensator. So main thing is to it will affect the voltage support. Okay, voltage support it will affect, and also ATC impact will be high. Okay, next if you take like STATCOMs, static compensator. So it will affect the reactive power control. So impact of ATC also high. Next comes the TCSC, thyristor control switching capacitor. So affect the serious compensation will be there. So ATC impact, if you take like redistributes the flow. If you take like UPFC, okay, like unified power flow controller. So effect is like a flow control will be there, and also impact ATC impact major ATC gets increased. So if you use UPFC majorly in the fax devices, they are using this unified power flow controller only. They are using the most. Sometimes they are using this SVCs and STATCOMs also. Whenever the voltage support is needed, they are using this SVC. Whenever reactive control is needed, they are using STATCOMs. Whenever the serious compensation, very less possibilities. They are also using this thyristor control series capacitance also. Next comes the grid reconfiguration. So out switching lines in and out sometimes okay for maintaining the ATCs. Next adjusting the tap change transformers, tap changing or onload tap changing transformers. By using that also you can reconfigure the grid. Next redispatching of generators based on the transmission capability. We can redispatch the generation. And also which reduce the congestion. If you so this by doing all these things which reduce the congestion, and also it increases the available transfer capability in the system, that means in the grid.